Ta-dum. Hello! Today's question of the day is, what is acceleration? An acceleration is a change in speed, a change in direction, or both. A change in speed could be getting faster or getting slower. If an object is not moving, or it is going at a constant speed in a straight line, that's key, you have to be going in a straight line, then the acceleration is 0. If you're not moving, your speed is not changing and neither is your direction. If you are moving at a constant speed and you're going in a straight line, well, one, your direction's not changing because you are going along a straight line. And two, well, constant implies that the speed doesn't change. So your speed isn't changing and your direction isn't changing, so you have 0 acceleration. I'm not accelerating! Now let's give some examples of acceleration. Let me accelerate into this. So that was an example of acceleration because I was running really fast, and in order to not run into my phone, I had to slow to a stop. So I went from moving to stopped, which means my speed changed, my speed decreased, so there was an acceleration. Okay, so there I had a constant speed, right? I wasn't getting faster or slower, but my direction was constantly changing. I was moving to the right, then to the left, then to the right, to the left. My direction kept changing, which means I had an acceleration. One of the most important examples of acceleration I can give you is when you throw an object up in the air. Did that ball accelerate when I threw it up? Well, first, ask yourself, did it change direction? 2, ask yourself, did it change speed? Well, it did change direction. At first, I threw the ball upwards, and then it came back down. So first it was moving up, then it was moving down. So yeah, it totally changed direction. Did the speed change? The speed changed too. I threw it up with a fast speed, and as the ball was going up, it was slowing down until it stopped momentarily, and then turned back around, and then it started speeding up again. So the ball's speed was always changing. So the ball changed directions, changed speeds, so it was accelerating. Now, what was causing that acceleration? Hopefully you gravitate towards the correct answer, but it was gravity. Okay, I'm done getting judgmental looks from everybody. Okay, question for you. Can you feel speed? If you've ever been in an airplane, can you tell that you're moving 500 miles an hour? Probably not. So right now we're on Earth. Did you know that we're moving over 1,000 miles an hour? Maybe you did, because the Earth is spinning. So right now we're all moving at a very fast speed. Can you feel that speed? No, I feel like I'm not moving right now. I can't feel that speed. So you cannot feel your own speed. But can you feel an acceleration? Can you feel a change in speed?
Or a change in direction?
I don't know. If you're at a stoplight, or hopefully your parents are driving, so you're stopped at a stoplight, and then the driver hits the gas pedal, and you take off from the stoplight. What happens to you? You lean back in your seat, right?
And your body got squished against the seats.
So that was a change in speed. You went from stopped to moving and getting faster and faster. Did you feel that? Yeah, you did, because your body went backward. You totally felt that.
You felt yourself get squished against the seat. So yeah, you totally felt that change in speed. You felt that acceleration.
What about if you're in the car on the freeway and you're driving at like 60 miles an hour or whatever, and then there's traffic. So the driver slams on the brakes. What do? You jolt forward. So again, that was a change in speed. You were going fast, and then you had to slow down, and you felt that change in speed. You felt that acceleration. So you can't feel speed, but you can feel a change in speed. You can feel an acceleration. What about when your car takes a turn? Like when you go around the corner. So what about if you're, rounding the corner in your car takes a turn. So you're going at a pretty constant speed when you turn, right? What's happening? You're changing direction. Can you feel that? Yeah, you do. You're not changing your speed, but you are changing your direction, right? Because you're driving this way and then you turn. and then you're driving that way, so you change your direction. So you can feel that too. So you cannot feel just a speed, but you can feel a change in speed or a change in direction, meaning you feel an acceleration. Just like on a roller coaster, when you're at the top and then you zoom downwards, you definitely feel that acceleration because you're stopped and then you go faster and faster and faster and you feel that. Acceleration is represented by the letter A. A. So I said that an acceleration is either a change in speed or a change in direction. But really, an acceleration, not only does it describe a change in speed or a change in direction, but it also describes how fast, how quickly you change your speed or your direction. So an acceleration is really a change in velocity over time. So if you're at a stoplight and you go from 0 to 50 miles an hour, so we have a change in speed, so we know there's an acceleration. Now, acceleration not only describes that change in speed, but also how long it took you to change your speed. Did it take you 3 seconds to get up to 50 miles an hour, or did it take you 10 seconds to get up to 50 miles an hour? You've got the same change in speed in both cases, so there's an acceleration, but the acceleration in each case is different because it takes you a different amount of time to get up to the same speed. In the first case, you would have a very large acceleration because you changed your speed very, very quickly. Hopefully, you push on the gas pedal more gradually. In the second case, that would be a smaller acceleration because it took you a much longer time to get up to the same speed compared to the first situation. And so you still accelerated, you changed your speed by the same amount, but it took you much longer to change your speed, so you had a much smaller acceleration. So an acceleration is a change in velocity over time. How fast do you change your speed, or how fast do you change your direction? Delta V is a change in velocity. So the triangle is the Greek letter delta, and it means change in. The V stands for velocity, so acceleration is a change in velocity over time. How can we rewrite change in velocity? Well, that is V final minus V initial, and all over time. So the change in velocity can be rewritten as a final velocity minus an initial velocity. Alright, now let's talk about the units of acceleration, and we can derive them. Remember, these brackets mean units, so units of acceleration. How am I going to get the units? Well, I'm going to look at the definition of what an acceleration is. Acceleration is a final velocity minus an initial velocity all over time. So what are my units of velocity? The units of velocity are meters per second. So I have meters per second minus meters per second on top because a final and an initial velocity are both measured in meters per second. And what's time measured in? Time is measured in seconds. So right now I'm just talking about units, not numbers, just units. So if I have two numbers with units of meters per second and I subtract them, I'm going to get a number with units of meters per second. And on the bottom I'm going to have seconds. Meters per second is equal to meters per second squared. So my units of acceleration are meters per second squared. The seconds is squared. Finally, my question is acceleration a scalar or a vector? So what I'm really asking is, does acceleration have a direction? Well, in the definition, acceleration is a change in velocity over time. Velocity is a vector, so we know acceleration also has to be a vector. But think about it without using the variables. But remember, we said earlier, acceleration is a change in speed or a change in direction. The key is change in direction. So if acceleration can involve changing your direction, then acceleration definitely has a direction. So acceleration has a direction. What does that mean? Well, let's say that you're speeding up. Like, again, the stoplight example. You're stopped at the stoplight and you're speeding up. Well, you could be speeding up in one direction or you could be speeding up in the other direction.
right? And in an intersection, cars are going both ways. So cars on one side of the intersection are accelerating in one way because they're going on one side of the road. And on the other side of the intersection, cars are speeding up, accelerating in the other direction. Acceleration most definitely has a direction. The direction you speed up or slow down in definitely matters.
Dun dun dun! So acceleration is a vector.
And so remember, we give vectors a little hat, a vector hat.
Hats off to you, you made it to the end.